Here is a little mystery before we start. Imagine drawing a perfect square that is exactly 1 meter wide and 1 meter long. Hold that thought, because today it becomes mathematics. Welcome to Math Concepts Made Easy. Today is day 2, and our lesson is all about irrational numbers. Before we start, a quick recap. In our last lesson, day 1, we studied rational numbers, what is a rational number, intuition and definition. If any of that feels unclear, pause here and re-watch day 1 first, because today builds directly on it. By the end of this lesson, student understands why root 2 cannot be written as P over Q and masters proof by contradiction. Grab a notebook, get comfortable, and let us begin. Before we touch any formulas, let me show you where this idea already lives in your everyday life. Imagine drawing a perfect square that is exactly 1 meter wide and 1 meter long. Now, draw a diagonal line from corner to corner. If you try to measure that diagonal perfectly, you will find something shocking. It is impossible to write its exact length as a simple fraction. You have been using this idea all along. Today we simply give it a name and learn its rules. So what is really going on here? This blew the minds of ancient mathematicians. They realized there are gaps between our neat little fractions. We call these unmeasurable numbers irrational numbers. Today, we are going to prove why the square root of 2 is one of them, using a brilliant method called proof by contradiction. Keep that picture in your mind, because everything else in this lesson grows out of it. Now we are ready to say this precisely, the way mathematicians do. Here is our focus for today: what is an irrational number? Proof that root 2 is irrational. In symbols, we write it as the square root of 2 is not a rational number. Every word of that definition matters, so read it slowly. You already know rational numbers, proof by contradiction. This definition simply builds on those familiar ideas. Here is the key formula for irrational numbers. The formula is, the square root of 2 is not a rational number. Watch how each part appears as I say it. Do not just memorize the symbols, make sure you understand what each one represents, because that is what the exam really tests. Let us put this to work with real examples, one step at a time. Assume the square root of 2 equals P over Q, where fraction is fully simplified. 2 equals P squared over Q squared, which means P squared equals 2Q squared. Which means P squared is even, which means P is even. Let P equals 2K, which means 2K squared equals 2Q squared, which means for K squared equals 2Q squared, which means Q squared equals 2K squared. Which means Q is even. Contradiction. Both cannot be even. Notice how every line follows logically from the one before it. That habit, checking each step, is what makes your answers reliable. Now, a quick warning, because I see students lose marks on this every single year. Before I show you, think about what could possibly go wrong here. 3, 2, 1. Students often think irrational just means a very long decimal. Correct this, even a very long decimal is rational if it eventually stops or repeats. Irrational means it never stops and never repeats. It literally cannot be built from whole number pieces. Compare the wrong way and the right way on screen, and promise yourself you will never fall for this one. Time to try it yourself. Here is your practice question. Classify 0.333 pi, the square root of 9, the square root of 5. Pause the video now, or take a few seconds with me. 5, 4, 3, 2, 1. Okay, let us solve it together. 0.333, which means rational, repeats. Pi, which means irrational, never repeats. The square root of 9 equals 3, which means rational. The square root of 5, which means irrational. How did you do? If you slipped anywhere, rewind and watch that step again. That is exactly how strong students learn. Let us bring today's lesson together in one picture. At the center of everything sits irrational numbers. We explored what is an irrational number, proof that root 2 is irrational. The one formula to remember is the square root of 2 is not a rational number. Watch out for the common trap we discussed. And remember our goal: student understands why root 2 cannot be written as P over Q and masters proof by contradiction. Next lesson, decimal expansions, terminating and non-terminating recurring decimals. New lessons every day on math concepts made easy. Thank you for learning with me. See you tomorrow.